Hello. Today we'll discuss about integration. Integration by numerical methods. So to start with this thing, let me just discuss what is the meaning of integration. So to explain this one, first assume you have a function, some function fx, and which was plotted with respect to x. X is the variable. For different value of x, one can get different value of a function. And you are plotting this thing. So this is the nature. Now, if you are considering the elementary parts, the smallest part of this function, which is represented by dx or along the function d of fx, this is known as derivative. So theoretically, this is the meaning of derivative. Now, if you want to go for integration, you need to add this. You need to add the elementary part from a certain limit. So here the limit is given as b to c. So within b to c there will be number of dx. You are integrating over this thing, so you can get the integral part of the function. So when you think about integration, you may think about this area, this pink area what we are talking. Now when you are thinking about integration, we are really talking about the area under this curve. Curve is representing the function, so area you need to consider. Today we will discuss about two methods of calculating numerical integration by numerical method. The first one is known as trapezoidal method. So in the trapezoidal method, what we are going to consider? We will consider this particular area as a form of a trapezoid. So basically when you think about a trapezoid, so there is a high chances of some approximation. But still we can minimize this thing to get a very accurate value of integration. So what we are doing to explain the trapezoidal method, let me just discuss about it graphically first. So you have a function, say you are plotting this function y is equal to fx along with respect to x within the limit of a to b. Now this is divided into several parts. Now one can think about the area under this curve a to b. Now here we can consider a trapezoid, something like this. So let me just take a different color so things will be clear to you. So you can have a trapezoid. But when you think about a trapezoid, so obviously there is a high chances of error in this. High chances of error. So this area, this portion of this part is not really inside the function part. So when you are adding this thing, there will be error. When you are talking about this part, this is also error. Now how we can minimize this? So to minimize this one, we are considering the smallest part of this. So we are, instead of considering a to b as a whole trapezoid, now we are dividing the part into small parts. So what we are doing here? We are dividing the variable from x0 to xn. So x0 here, this is a, whereas x of n, the nth division, is known as b. And the difference between x0 and x1 is given by h or delta x. Or in other way, one can think about b minus a divided by number of differentiation, number of dx part. So here number of dx is n given by h. So you need to consider number of trapezoid, add all those trapezoid. This will give you the area under this curve. And when you got the area under this curve, this gives you the integration over the function f of x. So how to find the area under this curve? So to find the area of this curve, one can really consider the area of the trapezoid. What is the formula for trapezoid? Area is simply, you need to consider base 1 and base 2 and the height between the base 1 and base 2. Same way, you can consider just consider this is x0, this is x1. So this particular point will be considered as f of x0, this is f of x1. This is f of x2 and the corresponding variable is x2. Accordingly, we can move up to this point. This is xn, so the corresponding function is f of xn. Now, we will consider individual trapezoid and we are going to add on. Let me just check it. So here, what we will go to do? We are going to consider 2 points. Now, when you are talking about the base of this, just imagine you have a trapezoid, something like this. You have a trapezoid. So, what will be your base height? So, this is our first base. Let's take it in another color. This is. So, what is this height steps? For this point x0, this point is f of x0. So obviously this particular height is along the y-axis. So this is the. So this height, the base 1, is given by f of x0, or you can consider f of x is equal to a. This point I have considered as x0, and this height is given as f of x. Okay, so height we have to. Same way, this particular height, this side of the height is given as, this is given as f of x1. Okay, so base 1 and base 2, we have got base 1 and base 2. Now what you need to find? We need to find the distance between the base 1 and base 2. What is this distance? Now we need to consider this distance. What is this distance known as? This distance is known as h, or this is delta x. So now you have both the sides, base 1 and base 2, and the distance between these two. Okay, so one can write this. So the area under this thing can be given as, okay, say instead of writing f of x0, I am considering this is y. This is equal to say y1. Same way, the second one can be considered as y2, y3. So what is a? A can be given as y0. Okay, so base 1 is y0 plus y1. So base 2 is given by multiplied with h divided by 2. So here height is given by h. The distance between this thing is h. So one can simply write this is h. Now this is the area of the first trapezoid. Area of the first trapezoid. Say I am considering this is A1. So what will be A2? In case of A2, you need to consider 2 points, x1 and x2. So how we can write it? This is y divided by 2. This is y1 plus y2. So what will be the yn? We can go for all of this thing up to y an. An is equal to a2 y n minus 1 plus y. Now you need to add to get the whole area starting from x0 to xn, or from limit a to b. So what you will get? Just see those equations. So y by 2 is common, and y by 2 is common. Just take y by 2 common and just try to get this thing. How many number of times y0 and yn is appearing in this equation when you are adding? This will appear only once at ya1, and n is appearing at an. But for other cases, when you are adding a1 and a2, now see, when you are adding a1 and a2, what you will get? You will get h by 2 common. Inside the bracket, this will be y0 plus, just see, y appearing 2 times. This will be y1 plus y1. So this gives you twice of y1. And the last one is y Now, if you are adding this thing with y3, so what this will give you? So what is y3? Let me just write it first. What is y3? y3 will be equal to h by 2 y2 plus y3. This one. Okay. So when you are adding this one, so obviously you are adding with y2 and y3 is left. So this will simply become twice of y3 plus, twice of y2 plus y3. So one can extend this one for generalized form up to n in number. So if you are considering n in number, so our equation simply given as, we just write it in reference form, write in a different color. So I, which is basically summation of a1 plus a2 plus a3 plus a4 up to an. So this will be simply given as y by 2 inside the bracket, y0 means f of x0 plus twice of y1. What is y1? y1 is f of x1 plus twice of y2 up to, okay. So if function is given, you can find the discrete values. You can find the values for x0, x1, x2, x3 up to xn. Okay, get the values, add all those things, multiplied with h by 2. You need to know what is the value of h by 2. This will give you the integration. Just check that one. Now this is the form. What you have? Integration limit a to b function. This is h by 2, y0 plus 2, y1, y2, y3 up to yn minus 1. All are multiplied with 2 because they are repeating 2 times. But y0 and yn appears once. This is the simplest form, and one can easily calculate the integration by using the trapezoid. Obviously, in the trapezoidal rule, there is a chances of error in the system. So if you have a curve something like this, you have some part of the trapezoid, but see there are some additional part. So some of the portion will be added externally. This will be added, which is not covering by the trapezoid, and some of the cases you can see some of the sections will be missing. So obviously there will be some error. But to minimize the error, what we can do, we can decrease the value of h or delta x. If your trapezoid values are very close to each other, obviously the number of n will increase. This will increase the computational time, but the error will be minimized by this. So this is the trapezoidal method by which one can calculate. And if you want to calculate the error by using this formula, one can calculate how much error will appear in case of trapezoid. Now we'll try to solve a function, integration over a function within a limit by using an online calculator. Now here we have taken a function under root x. So our function is under root x, x to the power half, within the limit of 1 to 2, limit of 1 to 2, and n is given as 5. So n is 5. So when you are calculating this one, so your solution is given by this. Just generalized formula h by 2 or x by 2. So y0 and yn, and all are other multiplied with 2. So what is h or what is x? This is b minus a by n. So what is b? b is 2 minus 1 by 5. This is 1 by 5. So h value is 1 by 5. So your interval 1 to 2, this will be divided into 5 equal subintervals. Okay, so the subinterval is given. So for these values of x, you can calculate what is the values of this This is given over here. When you have this thing, you can just add this one. You can just put this back in the formula and you will be able to calculate what is the area. What is the area under this curve by using the trapezoidal rule. So answer is given. Now comes the next part. This is known as 1/3 rule, Simpson's 1/3. In the same way, we will go to calculate the area under the curve. But here, what we have done, we have used some trapezoid. So this is a much more linear lines we are covering. All the 4 lines what we are considering, they are linear lines. So there is a high chances of missing some of the portion or adding some of the portion when you are talking about a curved section. Obviously, your function is some sort of curve. Now to minimize this thing, to minimize the error, one can use the Simpson 1/3 rule where the curve will be considered under the parabola. So when you think about a parabola within a certain limit of integration, we are really talking about a curved system. So you have a curved system and we are talking about parabola, number of parabolas, n number of parabolas you can consider. So here you will be able to minimize the error in the system. Now how to do this thing? Just consider a particular picture. Again, this is divided into A to B. N in number. It starts from x0, x1, x2 up to x of n. Okay. And this is divided into h. So h, again we know h is divided given as b minus a by n, or h or delta x. Now here we're going to consider just something like this. And we're going to consider the area under this. Again, this will be applicable for x0, x1, x2. Okay. So this will give you area 1. Then you can calculate area 2 with x2, x3 and x4 parabolas. This will be a2. Up to an you can consider. Add all of them and you can get the integration or the area under the curve. This will give you the integration system. So how to calculate this one? Now to do these things, we're going to consider the simplest equation. The simplest equation of a parabola. So what is the simplest equation or generalized form of a parabola? The generalized form of a parabola is given by ax square plus bx plus c, a generalized form. General form. So if you are able to integrate over this, so you will get the area under this. Now see, when you are integrating, a limit of minus h to plus h. Okay. So what we are assuming? We are assuming that here, so we are talking about a distance, a step size distance of h. So to simplify our problem, we are assuming this is 0. Say this is 0. So in this side, the distance is h. And in this side, distance is given as minus. So simply one can think about the integration starts from minus h to where? So what is y dx? Y dx is given as ax square plus bx plus c. Okay. So you are integrating over. Now when you are integrating this one, you have ax square and bx. But obviously, this particular factor will always be equal to 0 as the function is a constant. So what is left? It is left with 2ah cube by 3 plus 0 plus 2ch. Put the value, integrating over this and putting the value. And then simplification, this will give you h by 3, 2ah square plus 6. Now, We are considering 3 points, x is equal to 0, minus h and plus h. So we are going to put the values of this function. Put the values of function x0, this is minus h, x1, this is 0, and x2, this is. So if you put this values, what this will give you? y0 becomes ah square minus bh plus c. This is equation number 1. And here we put the value x is equal to 0. Obviously, a and b terms, the coefficient values will be multiplied with 0. So this will give you c is equal to y1. And the other term ah square plus bh plus c. This is equal to y2. Now, you need to solve this one. In simple way, c is given as y1. C is given as y1. So we can just rearrange this one. Okay. So by adding equation 2 and 4. When you are adding these two, okay, obviously this and this, they will vanish. So what is left? This will left with ah square plus ah square. This gives you 2ah square. Okay. This is y0 plus y2. y0 plus y2 terms. And we have twice of c. c plus c. Twice of c. And what is c? c is given as 1. So one can write 2ah square. This is equal to y0 minus 2y1 plus 1. Okay. Now this is represented as equation. Now we have a term 2ah square. If you refer equation number 1, where is this equation number 1? Yes, yes. You have a term 2ah square. So we are going to put this. Now you know 2ah square. What is the value of 2ah square? And also we know what is c. c is y1. Put this value and simplify it. So when you go to put this back, 2ah square. 2ah square value is y0 minus 2y1 plus y2 and 6c. 6c is 6y1. So it simply becomes h by 3 y0 plus 6 minus 2, 4 of y1 plus y2. Okay. So put this back. Is simply given to the area under the point x0 to x2. You can repeat it. You can repeat it for x2 to x4. So one can simply write this will become h by 3 under this one. Okay, x0 is x0, so this will be x of 2. Okay, the second term becomes 4 times of this one, so this will become 4 of x plus this will be y1, this will be y3, this is y2, y3 and y. Same way this can be repeated for y4 to y6. Same terms will be repeated. And we need to add the 4 terms. Let me just add the first 2 cases. Again, y by 3 will be taken common. y0 single time repeated, so this will be y0. y1, how many times this is repeated? The 4 times, so 4 into 1. Now see how many times y2 is repeating. y2 is repeating 2 times. So if you add all those for x0 to x4, just I am considering x0 to x4. So what will be x0 to x4? This is 1 by 3. Inside the bracket, what this will be? y0 plus 4 of 1. Okay, plus y2. How many times y2 is repeating? This is 2 times. Plus 4 of so we have considered a range of x0 to x4. Now see, for this range, the odd values, odd function values are multiplied with, whereas evens are multiplied with 2. You may think about 4 to 6, so this will be twice of y4. So this is our generalized equation. So area is given as h by 3 y0 plus 4y1 plus 2y2. So you can see all the odd numbers are multiplied with 4 and all the even number of functions multiplied with 2, where y0 and ya are repeating only once. This is the generalized equation of this thing. Again, when people are trying to calculate this thing by this 1/3 method, still there will be some approximation. Obviously, this will be lesser approximation, but still we will have some approximation. We can calculate what will be the error in the system by using this formula. Now let me just check it by a online calculator. Again, we have taken a same sort of function, root of x within the limit of 1 to 2. But remember, the n in case of 1/3 method is always be a even number. N should be even number. Earlier case we have taken 5. Okay. Here this should be even. So this is x0 to x5 in case of trapezoidal. Here subinterval should be x. This will be L. Again, the formula is simply calculated as the limit is b minus a 2 minus 1 by 6. So h or delta x is 1 by 6. So the interval, the subinterval will be divided into 1 by 6 terms. So 1 and then you can divide. Get the values of the function corresponding to x values. x1, x0, x1, x2 up to x. And then add all of this. H by 3 multiplied with 4 times of the odd values, odd function values, 4 times of odd function values. Just multiply this thing. Here this will be multiplied with 4. Okay, this is given as 4 of this. This is multiplied with 4 of this is multiplied with, sorry, I'm just represent this 2 and 3. Okay, these are the odd values, odd function values. Whereas the evens are multiplied with 2. This is 1. Whereas the first one and the last one will be single. Add this one and you will have the area under this curve or the integration values of this. Now you can have an alternate method of calculating the integrating part. So this is known as Newton-Cotes formula, generalized quadrature formula or equidistance formula. If you have a function series, generalized function series, when we integrate this one, this will look something like this. Now if you put n equal to 1, you will appear with a trapezoidal. Okay, just you put n equal to 1 in this equation and you will appear in this form. So at the end, one can get a expression something like this, where the first one plus last one and twice into all the terms. This is the trapezoid. And again, if you just put n is equal to 2, this will give you Simpson 1/3. Just check that one. Put n equal to 2, this will give y by 3, y0 plus yn, first term and last term, and 4 into all the odd function values plus 2 into all even values. This is the Simpson rule or Simpson 1/3 rule. This is h by 3. So this is 1/3 of h. So this is called the 1/3. A simple recapitulation. A function, when you are integrating, you are really covering certain area. The area will be approximated by trapezoid. So the trapezoid rule means simple addition of two bases, sides of two bases, and the height, the distance between the bases. This will give you the trapezoidal form. So simply one can approximate the trapezoidal formula by using this. So here, except the first and last term, all the other function values will be multiplied by 2. In Simpson 1/3, this will be used by a parabola. Now here, the function values will be multiplied. First and last will be appearing 1, but the even function is appearing 4 times, and the odd, even functions, they are appearing 2 times, and the odd function, they are appearing 4 times. Add all of them and you can have the integration. Thank you.